Unit 5 is about the binomial probability distribution, and Section 5.1 deals with expected value. So a quantitative variable, a number x, is a random variable if the value that x takes on in a given experiment or observation is a chance or random outcome. A discrete random variable can take on only a finite number of values or a countable number of values, like the number of students in a class. It wouldn't make sense to say that there are 20 3/4 kids in a class. It'd be 20 or 21. A continuous variable can take on any of the countless number of values in an interval, like the heights of the students in a class, because you can have somebody who's 5 feet and 6 1/4 inches or something like that. So go through these, decide if the measurement is discrete or continuous. The time it takes to finish the final exam, that's continuous. It can be fractional amounts. Letter B, number of checks written, would be discrete. Letter C, pick a random sample of 50 registered voters, would be discrete. And the amount of gas needed to drive your car 200 miles would be continuous. A probability distribution is assignment of probabilities to each distinct value of a discrete random variable or to each interval of values of a continuous random variable. So what you see here is a graph of the probabilities of picking a single Scrabble tile, and it's just one. So just one tile. So obviously E has the best chance of getting picked, and there's a couple tied for last, like J, K, Q, X, and Z. That's a probability distribution. The mean, or the average, of a probability distribution is often called the expected value of the distribution. The standard deviation is often represented as a measure of risk. A larger standard deviation implies a greater likelihood that the random variable x is different from the expected value. So down here there are a couple of computations for expected value. This down here, this symbol here is called mu. It has a little tail like a U, but it's called mu. It's Greek. And what you do is you sum the variable value x times its probability p of x, and then you sum all of those together to get the expected value. This right here is the calculation for standard deviation, but we would probably just use a calculator to do that. So at a school carnival, you are operating a game where you have a person pay $2 to play a coin flipping game with 3 fair coins. They flip the 3 coins and they win $1 for every tail that appears on top. Are you charging enough money for the game? Well, here's the sample space. So there are 8 total things that could happen, all the way from 3 heads down to 3 tails. So if they get $1 for every tail that comes up. So the probability of 0 tails, so that's heads, is 1 out of 8. So right over here, 1 out of these 8. The probability of 1 tail is 3 out of 8. So 1 here, and 1 here out of 8. 2 tails is 3 out of 8. So 2 tails here, here, and here. And then 3 tails is 1 out of 8 right down here. All right, so those are the probabilities of 0, 1, 2, 3 tails. Also thinking in terms of this game, if you get 3 tails, you get $3. So expected value would be the 1/8 times the expected, or I'm sorry, the value 0. You get $0 with the 0 tails. 3/8 times $1. 3/8 times $2, and 1/8 times $3. You do that all, and you get 1.5. So contestants can expect to win $1.50 on average, which means you can expect to make 50 cents of profit overall on average per person. So here's an example. A $20 bill, 2 $10 bills, 3 $5 bills, and 4 $1 bills are put into a bag. If a bill is chosen at random, what is the expected value? So the probability of getting the 20 is 1 out of 10, 2 out of 10, 3 out of 10, 4 out of 10 for the rest. So expected value would be taking these probabilities and multiplying it times the value here. So 1/10 times 20 plus 2/10 times 10 plus 3/10 times 5 plus 4/10 times 1 gives you an expected value of $5.90. Again, you have to understand that is on average. If we kept doing this experiment over and over and over again, and kept track of all the money that we would take out, it would be $5.90 on average. So let's try letter A. A game consists of rolling a 6-sided die that has 3 blue sides, 2 red sides, and 1 green side. Rolling a red side loses. Rolling a blue side wins $2, and rolling a green side wins $6. What is the expected value of the game? And if you were charging people money to play, what would you charge? So the probability of rolling, what was it, $2 for a green is 3 out of 6. Well, I'm sorry, that's rolling a blue. $2 is rolling a blue, so it's 3 out of 6. Rolling a green is $6, so it's 1 out of 6, and getting nothing is 2 out of 6 because that's the red side. So again, we're going to take the probability times the amount. The expected value is $2. So contestants or whoever's playing this game can expect to make about $2. So what should you charge? More than $2. Company believes it has a 40% chance of being successful on bidding on a contract that yields a profit of $30,000. It costs $5,000 in consultant fees to prepare a bid. What is the expected gain or loss for the company if it decides to pursue the contract? So the probability of getting the bid is 40% or 0.4. So the expected value is 0.4 times the $30,000 in the bidding contract, or just the contract. So that's $12,000. So their expected value, $12,000. Take away the $5,000 in consultant fees, they're expected to gain $7,000. Here's another one. Valentine's Day, the Quiet Nook restaurant offers a Lucky Lovers special that could save couples money on their romantic dinners. When the waiter brings the check, he'll also bring the 4 aces from a deck of cards, hearts, clubs, diamonds, spades. He'll shuffle them and lay them face down on the table. The couple will then get to turn 1 card over. If it's a black ace, they'll owe the full amount. If it's the ace of hearts, they get $20 off their meal. If they turn over the ace of diamonds, they'll get to turn over one of the remaining cards. If that card is the ace of hearts, they get $10 off of their meal. What is the expected discount for a couple? So the probability of the ace of hearts is 1 out of 4. And we want to calculate, or we would also have to calculate the probability of the ace of diamonds and then the ace of hearts. So it would be 1 out of 4 times 1 out of 3. That's 1 out of 12. So the expected value would be the probability of getting the ace of hearts times 20 plus the probability of ace of diamonds, then ace of hearts times 10. That's $5.83. So a couple can expect a discount, again, on average, of $5.83. And that was the end of 5.1. It was all on expected value. Please let me know if you have any questions. Thank you.